Good morning, everyone. My name is Anjali Vishwakarma. I'm professor of SART. So, in today's YouTube lecture, I will discuss about the data structure. So, if I'm describe this word data structure, if we divide this data structure word in two parts, that is data and structures. So as we all know that any information regarding anything is called data, and the structure is a representation of particular thing. So if we want to provide a structure to our data, then this is called data structure. If I'm talking about the definition of introduction of data structure, then data is something that we have of related with anything, like if I'm talking about the students, then student have their data, employee have their data, hospital management have their data, school, colleges, everything have their data. So these data are in a large amount, and we want to provide a structure to the data, because at later time if we need this information, then we can extract that information clearly, or in a feasible way, in a reliable way. So we provide a data structure to data, so we can clearly identify each and everything about that. So data structure is a representation of the logical relationship existing between individual element of data, or we can say that if we organize the data in some form, then this is called data structure. So uh, these data structure, different types of data structure according to our use, according to our application we use, we provide data structure. Like if we have data related with the student, then student name start from A to Z. If we can provide a structure, like we can organize data in a sequence, like we can organize the data in alphabetical order, so it will very easy for us to extract that knowledge or extract that information at later time. So here we provide different types of structure to those data or information, so that we can clearly identify, or anyone else who want to use the data, then he and she can easily catch the data at the later time. We can classify this data structure in two parts, that is primitive data structure and non-primitive data structure. If I'm talking about the primitive data structure, so the integer, float, character and pointer are the primitive data structure. And if I'm talking about the non-primitive data structure, the non-primitive data structure is again divided into two parts, that is linear list and non-linear list. And this linear list is again divided into four parts, that is array, linked list, stack and queue. And non-linear data structure is divided into two parts, that is graph and trees. So by using sorting technique, we also can arrange the data in some form, and some form can be increment to decrement order, or decrement to increment order. Now firstly I will discuss about the primitive data structure. So they are directly operated upon machine instruction. They have different type of representation. Integer, float, character, pointer are the examples of primitive data structure. If I'm talking about the non-primitive data structure, so they are the sophisticated data structure. They are derived from primitive data structure, and they have group of homogeneous and heterogeneous data items. Now non-primitive data structure, as I divided in some form, some part, and these parts are list, stack, queue, tree and graph. Every data structure of non-primitive type have their own application. According to our application, we can use this type of data structure. So non-primitive data structure, so as I already talked about, the non-primitive data structure are graph, tree, stack and queue, and they have their own operation. Like whenever we have to add the data, then we apply the insert operation. Whenever we have to delete some data, then we apply the delete operation. If we want to check the data structure is this empty or not, so then we apply the empty or merging and sorting. These are different types of operation. Like create, whenever we want to create a data set, then here we use the operation that is called create. Whenever we have to select any particular uh, select cell, then we can apply the selection. Then if you want to update the data structure, then we apply updating. Then searching, if we want to search anything, we apply sorting technique. As I already talked about, we have data and we want to arrange data in some alphabetical order, and increment and decrement order. So here we use the sorting techniques. Merging, whenever we want to merge the data in two, if they have two parts and we want in a one part, then we apply the merging. And whenever we have to delete the data and we want to insert some other data, then we can apply the destroy and delete operations. If I'm talking about the if I differentiate between primitive and non-primitive data structure, then we can say that non-primitive data structure are derived from the primitive data structure, and the primitive data structures are basically structures that is usually built into the language such as integer and float. And if I'm talking about the non-primitive data structure, they have different types of structures we use to put the data, like we can use trees, graphs, and trees are again divided in lots of form like B tree, binary tree, AVL tree, and binary search tree. So these are the non-primitive data structure. So firstly, if I'm talking about the array, this is again a data structure. Then it contains sets of finite numbers of homogeneous elements. We can declare, or we can define the array is a bracket size of mathematical symbol, and we can write like ARR in a small letter that describe the array. So this is what the array. So this is what, and here we can define a program, or we can write an algorithm or program related with that array. So if you are reading or writing two-dimensional, again I'm saying that firstly, if I'm talking about the array, then it is a homogeneous and heterogeneous collection of data items, and this array is divided into two parts, that is single and multidimensional. Multidimensional is also called two-dimensional array. So in two-dimensional array, we use a matrix form to store that information. So there are the different types of operation in an array, like insertion of a new element, deletion of required element, modification of element, and merging of array. Now the next data structure is a list, in which we can insert data in a sequential form. Lists are commonly used in non-primitive data structure. They also have their structure, like this is what the linked list structure. Here the information field and pointer field, the other two field here. So this is what's the list, and there are different types of lists like single linked list, doubly linked list, single circular linked list, and doubly circular linked list. Now again and the another type of data structure is a stack data structure. Here the structure of the stack is like a square in a rectangle in a vertical order, we can say. Here we can firstly we will check if there is empty, then if it is not empty, then we insert the data. So this is the order collection of element of array, but it has a special feature that deletion and insertion of element can be done from the top of the stack. And in this the data item as a due to this property, it is called last in first out of data structure. It means the last item that will be added will be the first item that will be deleted. So this is what the last in first out stack. So it is, and again non-primitive data structures. So this is the structure of stack. Whenever we have to add the data, then we say that we apply pop operation, and whenever we want to delete the data, then here we can apply push operation. So these are the two things in the stack. Whenever we have to put the data, then we call this is a pop operation, and whenever we have to delete the data, then we said this is a push operation. And whenever we have to count how many entries we filled, then we apply count operation. So there are three types of operation in the stack, that's push, pop, and count. So the stack can be implemented in the two ways, that is static implement and dynamic implementation. If I'm talking about the static implementation, here we use array, and for the dynamic implementation, here we use pointer. Now the queue is the first in first out type of data structure. It means the first data that will be added will be the first data that will be deleted. So in this there are the two things, that is rear end and the front end. Queue, as we all know that if someone is we can say that lots of persons are waiting for something in a line, that this is also called peoples are standing in a queue. So each new person comes and stand at the end of the row, and person getting their reservation confirmed get out the row from the front end. The below show figure how the operation take place. This is the front and this is the rear. So Q again divided into two parts, that is static implementation, dynamic. We can implement Q by using two things. These are array and pointer. This array is called static implementation and pointer is called dynamic implementation. Now the again next non-primitive data structure is a tree. In this there are the different types of tree where we can store the data or we can represent the data, like binary tree, B tree, AVL tree. These are the common, most important and most commonly used data structure in a tree. So a tree can be defined as a finite set of data items. Tree is non-linear type of data structure in which data items are arranged and sorted in a sequence. Tree represent the hierarchical relationship between the various items. So this is what the structure of the tree. This first node is also called root node, and again this root is divided into some parts, and these parts are called child nodes. So graph is another type of non-primitive data structure. Has the different types of graphs we use: connected graph, fully connected graph, and there are different types of again graphs, and we can define graph by V and E. V is called verticals, E called edges. So this graph is a mathematical nonlinear data structure capable of representing many kinds of physical structure. It has found application in geography, chemistry, and engineering science. And I as already said, already told about that graph represented by G and V. G represent graphs and VE represent the vertices and edges of the graphs. Each connecting a pair of vertices, and many have weights such as length, cost, and another measuring instruments. Vertices on a graph are shown as point of a circle, and edges are drawn as arc or line of segments. So these are the identification of graph in which we define by the vertices, edges, and self loops and the arcs. So this is the representation of graphs. This is a directed and undirected graph. Someday we can again classify these graphs into connected graph and non fully connected graph. So this is what the graphs, and there are different types of graphs as well, like directed graph, undirected graph, simple graph, weighted graph, connected graph, and non-connected graph. In this we can find the shortest path. There are different types of mathematical questions related with the graph. So here we have to find the shortest path between the 2 points. So in which we will write some of the formulas to get the shortest path. Then after we will get the shortest path. So this is what the data structures. So thank you so much.